In today's lesson, we are going to be looking at graphing the vertex form. So in our previous lesson, we did look at the vertex form. We looked at trying to determine the characteristics of it, the general shape of it, what it looks like, just by looking at the equation. And now we're going to look at actually graphing it. So the first thing we want to touch on is a new concept. It is one of the pieces of information that our vertex form equation does give us, and that is the step pattern. Now the step pattern, or the basic step pattern for a quadratic, is 1, 3, 5. So the basic step pattern is 1, 3, 5, and what that is telling us is that is basically giving us directions from one point to the next in our quadratic. So we always start at the vertex, and then what it tells us is that we go over 1 and then up 1, and then that's going to give us a point. What we do then from that point is go over another 1 unit and then up 3. And then that tells us the next point. And then from there, we go over another 1 and up 5. And that gives us a third point. So that pattern of the 1, 3, 5, it basically gives us directions from one point to the next. So it's going to tell us where 3 points are. To find the step pattern of a parabola or of a quadratic, we look for the a value. And when we find the a value, we multiply that basic step pattern, that 1, 3, 5, by that a value. So if I have my basic quadratic, I have it here. We have our vertex here, and I'm going to label all the key points on both sides. And we're going to take a quick look at what the step pattern is. So if I look at the step pattern, I go over 1 and I go up 1. So that first step is going to be, I'll put step 1, right, because we step up 1. We go over 1 again, and then we go up 3. Or maybe we'll change it to 1 step. We'll say 3 steps. And then we go over 1 again, and now we go up 4. 1, 2, 3, or 5, sorry. 1, 3, 5, so 5 step. So that step pattern tells us how to get the next 3 points from our vertex. Over 1, up 1, over 1, up 3, over 1, up 5. And it does repeat on the opposite side as well. 1 and 1, and then 1 and 3, and then 1 and 5. And that makes sense because of the fact that our parabola is symmetrical. So we should see the same thing on either side. Right, so if we know the vertex, if we know where it is, and if we know what the step pattern is, we can then go through and plot our points, or at least some of our points, enough to get a general idea of what it looks like. So for example, the step pattern for the quadratic y equals 2x squared would be 2, 6, and 10. Because we take that general pattern, 1, 3, 5, and we multiply it by 2, or everything by 2 because of this a value here. 2 times 1 is 2, 2 times 3 is 6, 2 times 5 is 10. And because it is a positive a value, it is going to open up. Because we go over and then up, over then up, over then up. The step pattern for the next one, or for y equals 0.5 x squared, would be, well, first we got to find our a value, which is the value in front of the x squared. So that means we multiply this basic step pattern. I'm going to write it up here. One, 3, 5. So I multiply that 1, 3, and 5 by 0.5, and I get 0.5, 1.5, and 2.5. So that means we go over 1, up 0.5, over 1, up 1.5, over 1, up 2.5. And the parabola would be opening up because it is a positive value. So that we should remember from our previous lesson, but the step pattern will be new. Next, we can put kind of below if we want 0.5 times 1, 0.5 times 3, 0.5 times 5. The next one, the step pattern for negative 3x squared, we have our a value, and this would be negative 3, negative 9, negative 15 for our step pattern. And again, how we get that is negative 3 times 1, negative 3 times 3, and negative 3 times 5. So we're just multiplying that basic step pattern by the a value. Now this one's a little different because it's negative, so this means we go over 1, and now we go down 3. Over 1, down 9. Over 1, and then down 15. So because of that negative, right, the negative means we're going down and not up. Right, so we're going over 1, down 3, over 1, down 9, over 1, down 15, and the parabola opens down, right, because of that negative. Right, so we just have to make sure that we find our step pattern by using that a value, multiplying our basic step pattern, the 1, 3, 5, by that a value. And if it's negative, you go down. If it's positive, you go up. Some other important things to remember or to know, right? When we're looking at a quadratic has an x squared in the equation and no other x with exponents. So we only want to see the highest exponent be x squared, right? So 2x squared plus 2x minus 3 is a quadratic. However, 2x squared plus 2x cubed minus 3 is not, right? And that's because of this x cubed that's causing the problem. So that's the reason that it's not. Right? If we're using a table of values, remember the first differences are the same. It's linear. And if the second differences are the same, then it's quadratic. The a value tells us the direction of the opening, as well as if there's a compression or a stretch. So again, stretch, we kind of think of it as skinny. Compression, we can think of it as wide. H affects the horizontal movement. So horizontal movement, so this would be left and right. So you can think of H as horizontal. Right. One thing to note that since the negative is part of the equation, our H value is always will have the opposite sign as shown. Right. So whatever we see, it's going to be the opposite. K represents the vertical movement. So this is up or down. I guess we can go back. Left if it's negative, right if it's positive, up if it's positive, down if it's negative. Right. The vertex will have a value of HK. So again, straight from the equation. Right. And then again, just a quick reminder, the general form, we don't have it written down, or the vertex form, y equals ax minus h squared plus k. So those are the three values that we're talking about, the ones we've looked at in the previous lessons. That's the general equation that we're dealing with. So let's look at the first parabola. Right? The quadratic relation y equals 2 times x plus 1 squared minus 8. Anytime we're given the quadratic in this vertex form, we just want to always try to find the a, h, and k, because those three variables do tell us important things about our quadratic. So again, the a value will be the one in front of the x squared, or in front of the bracket. So we have an a value of 2. The h value is in the bracket. with x and the k value is outside. So just from this equation, we can get quite a lot of information. Right? The first thing we can get is the vertex, because the vertex is our h and k. Now, however, just keep in mind, we did say that for the h value is opposite of what we see in the equation. So in the equation, h appears as positive 1, but that means then that our h value is actually negative 1. So the h value is negative 1, and our k value, as is negative 8. The parabola opens up because of the positive a value. And our step pattern, right? We take our basic pattern, the 1, 3, 5, and we multiply everything by 10. Or not 10, sorry. We multiply everything by 2 because of that a value of 2. So that means our step pattern is going to be 2, 6, and 10. Because our a value is 2, it becomes 2, 6, and 10. So that a value multiplies each step. And again, that step pattern is kind of giving us that, that directions from the vertex to the next points. So I can plot my points now, or at least my vertex. So negative 1 and negative 8. Graph my vertex down here. The step pattern is going to tell us where the next points are. So I go over 1 and up 2. Then over 1 and up 6. Over 1 and up 10. And that doesn't fit on our graph, but that's okay. We'll say it goes up, so we're going up 10. And I can do the same thing on the other side. Over 1 up 2. Over 1 up 6. Over 1 up 10. And again, we won't see that part. But I can at least draw in my other points, at least the 3 or the 4 other ones, and then roughly sketch what it will look like. Right, so again, you don't really need to draw in those steps, but it is helpful to get an idea or to help you draw those points, or as you're learning how the step pattern works. Right, so it's okay to draw in these steps, but you don't have to if you're comfortable with the step pattern. Right, so from our graph, we can see a couple extra things now. So the zeros, which is another term for the x-intercepts, we can see where the x-intercepts are, where it crosses the x-axis. They are negative 3 and positive 1. The y-intercept, we can see it crosses nicely at negative 6, or we can say 0, negative 6. I guess technically we could say that as well. Negative 3 and 0, if we just put the points, and 1 and 0. Our y-intercept is 0, negative 6. Our optimal value, this is the maximum or minimum. So our optimal value, it means our max or min, and it's the y value of the vertex. So the y value of our vertex is negative 8, and it would be the minimum. The axis of symmetry is that vertical line that divides our parabola in half. And an easy way to find it is the x value of the vertex. And because it's a vertical line, it's always going to be in the form x equals and then a value. Let's use a different color here. So the vertical line, and again, you don't necessarily need to show this. I'm showing it just so we get a better idea of where it is. It is that vertical line that goes through or divides our parabola in half, and it has the equation x equals whatever the x value of the vertex is, which in this case is negative 1. Right? So again, you don't need to draw that in there. If it helps you identify what the axis of symmetry is, you're more than welcome to. But again, you don't need to if you're asked to find it. So that's graphing our vertex form equation. We're graphing the vertex, and then we are looking at the step pattern to help us find other points. Right? The vertex itself does give us some key information, or the vertex form itself does give us key information, and we can then use that to graph it and help us find additional information. Now, sometimes the zeros and the y-intercepts might not be as nice as they appear here, right? So in some cases, you might have to estimate, and we'll look at scenarios later where we can actually calculate what those values are. The next one, we're going to do the exact same thing, just with a different equation. So y equals negative x minus 3 squared plus 4. Again, the vertex is h and k. So we should actually go through, because it's vertex form, find our a, h, and k. Our a value is going to be out front. Our h is going to be in the bracket with x, and our k is going to be outside at the end. One thing to note, I don't see a number in front, but I do see this negative here, which implies that there's a negative 1. There's an invisible 1 here that is negative that would be out front. And we do want to remember that, because that will help us with our a value. So our vertex, with our vertex is our h and k. It's exactly as we see, or our h is opposite of what we see. So instead of negative 3, it's positive 3. And our k we take exactly as is, which is 4. So our vertex is 3, 4. The parabola here opens down because of the negative a. The negative a value tells us it opens down. The step pattern is -1, -3, -5. And we get that from the basic form, which was 1, 3, 5. Because our a value is -1, we multiply each of those by -1, which just changes the sign. So I can graph that now. I can graph this equation now, because I can find the vertex, which is 3 and then 4. Again, make sure we know how to plot points, x and then y. So we have our vertex. We have our step pattern, because now it's over 1, down 1, over 1, down 3, over 1, down 5. And the same thing on the other side. If you don't want to show this step pattern on both sides, what you could do is plot your points on the one side and then just mirror those points on the other. I now have points that can connect, and just quickly sketch my parabola. Again, from here we can find our zeros, or the x-intercepts. Our x-intercepts in this case, where it crosses the x-axis, are 1 and 0, and 5 and 0. Our y-intercept, where it crosses the y-axis, is 0 and -5. The optimal value, remember, this is the y value of the vertex, so this is 4. It is a maximum as well. And the axis of symmetry is the vertical line that goes through, or that divides our parabola in half. It does go through the vertex, and it is specifically the x value of the vertex. So x equals 3. So again, the main thing from this lesson is just being able to take our vertex form, find the vertex, find the step pattern, understand how it's opening, and then graph it or sketch it accordingly. Right? So again, the main thing is just using that vertex as a starting point, and then using your step pattern to help you find other points, and then you can mirror those steps on both sides of the both sides of the vertex to get that symmetry. Once you graph it, you should be able to identify other key features, such as the x-intercepts or the y-intercepts, the optimal value, and the axis of symmetry.